Hey everyone, this is FixReef, and today we have this Apex EB832 in for repair. Now this unit is supposed to be a warranty repair. The history is that previously I received this unit with the most common problem of 12-volt power supply upgrade. I replaced the capacitors, sent it back. The customer says that he plugged it in, and the smoke came out of it. I asked the customer to please send it back so I can take a look at it. And while he was replacing this with another unit, he plugged that unit in again, and it also smoked. So now I actually received 2 units from him, and I suspect that the problem is not a warranty repair, but something else, something that he plugged into this unit that caused the problem. That something, according to the customer, is a mag drive pump that basically blew up both of these EB832s. I have absolutely no idea what the problem is at this point yet, so let's open it up and find out how much damage that pump caused. There are similar issues that I hear from other customers who would plug in a heater that eventually blew up, shorted, caused the problem inside, other larger pumps, return pumps, skimmer pumps, filter pumps, that type of thing. Let's just open it up and see what's inside. Hopefully it's repairable. I don't see a complete war zone inside, so let's keep disconnecting things. I can recognize the upgraded capacitors that I put into this power supply from before, so that's all good. Yeah, I am not seeing a damage that I would expect, the type of damage that I would expect to see. Let's keep disassembling. Uh-oh. Uh-oh. That's not a good sign. So what could have created that much smoke? Ooh, yes, look at this. Look at this. So what actually happened? Let me zoom in, you can see this all for yourself. We don't even need much of a microscope for this. Okay, so R2 or R7 I should say is completely gone. That R7 is similar to this R, I guess 8, and this R11 and this R12 and all of this. These are the shunt resistors, and this is exactly how this unit measures the current at each individual outlet as the current travels through this shunt resistor. Now, I think we have a bigger problem than this, just this shunt resistor. I see something here. You can't see it yet, but I see something here that may suggest that the controller is busted, which is not a good thing. We can likely clean out the damage here. I don't see much of a problem. There is not a whole lot that was happening next to it, so it really didn't get damaged too much. But my concern is with this controller. So let's get under the microscope and take a closer look at everything. So you should be able to see the type of problem we have. The shunt resistor is completely gone. And let's look at, oh, the controller I think is okay. It turns out that this is just probably either a piece of glue or a piece of flux that got stuck to it, but it does not look like it's actually a hole in the controller. That makes me feel better. Doesn't mean the controller is good, it just means that it's not visibly a hole. Well, alright. So let's see how much of all of this we can actually clean up. Let's see if we can get all of that mess off. And it does come off easily, unlike a significant burn-in damage on these boards when something like a MOSFET dies. That surface damage on such a large board is not that big of a deal. And you can see that I, for the most part, completely cleaned it. Alright, I think now would be a good time to actually clean up all this excess flux, and for that matter, any other dirt. That looks relatively clean, and it's still salvageable. Okay, now let's add a little bit of solder to both pads. See how much we can get out of here. That's still pretty decent. The goal, of course, is to make sure that there's going to be a lot of current going through this resistor, so just need to make sure that we have enough of a conductivity to make it work. Now a new resistor is going in. And I should be able to just use my solder iron to put it in place. That should be good. Okay, so let's see what else could be wrong here. Now, because we know that this shorted so bad that it blew this resistor off the board, it's reasonable to expect that whatever this was connected to, because again, this is a shunt resistor, they're measuring current going across this outlet here. So, and they're doing so using these big controllers. So my concern is, did this now damage the controller? Well, let's see. So there are a couple of the smaller traces that go under this small controller here. But I'm not sure if that controller is actually involved in current sensing in any way. If we look down here, yet another shunt resistor has the leads go into this quad resistor over here. This is a 1 kilo ohm resistor that then connects that to the pins on the controller. So you can see that these two pins are used by this resistor and these two pins are used by this resistor. And the traces go under, they likely go under this whole controller and come out and connect here. So let's just measure what condition this resistor is in. Okay, let me see if I can make it so that you can see the data. All right, so let's measure the good side of this first. So 102 means a 1 kilo ohm resistor, and that's a 1 kilo ohm. Also 1 kilo ohm. Also 1 kilo ohm. And 500 or 450 kilo ohm. That value is not good. I think we found our second problem. This quad resistor needs to be replaced. Okay, so here it is. And let's take this guy off. Just like that. And while we're at it, we might as well clean up the pads. Nice and clean. And I might as well add some fresh solder to it, and then we'll do cleanup and the reinstall. Looks brand new. Now just a little bit more flux. And let's install the new resistor set. Nice and easy. Nice and easy, just like that. Yeah, check out, nice and clean. Okay, very good. Okay, now with the resistor replaced, let's see if that fixes the problem. I'm hearing some type of clicks, but I still don't see the voltage. Nope, still doesn't work. The only clicks that I hear would be the 24-volt links. All right, at this point, I'm wondering if controllers are bad. Okay, let's continue troubleshooting this board. So what happens is we have a dead short across this resistor, and it's not the resistor that's causing the problem. We've verified this. Let's find out where that leads to. It turns out that these two optocouplers are being controlled or feed information into this controller. Basically, this pin is connected to one of these two, and this pin is connected to one of these two. Currently, what happens is that both of them are shorted to ground. This is shorted to ground, and this is shorted to ground. So these two pins on the controller are also shorted to ground. The big question is the short caused by the controller, or is the short caused by something else that it's connected to somewhere else on the board? The way I see it is because all the low voltages on this side of the board, most of it anyway, it's likely the controller. I doubt that that's going to be the optocouplers. Actually, first, let's verify where the short is. So this is the short to ground. Here's my ground, and it's shorted, and it's shorted, and even this is shorted. As expected. Once again, ground everywhere. This is supposed to be ground, so this is supposed to be valid, but this is not supposed to be shorted, and this is not supposed to be shorted. But over here, that's where it goes to into the controller. It's shorted to ground, and it's shorted to ground, and these are the two direct links to the controller. Okay, so let's go ahead and remove the controller and see if the short goes away. I want to even use the microscope for this. Okay, hopefully I didn't knock any other components off. And let's now see if the short is still present. Hopefully it is, because if it is, we will actually be able to find it and fix the board. But if the short is gone, the controller is gone, then we have a problem. Okay, here's my ground. And the short is still present, but not on here. The short is now gone from here. But it is still present here. And the reason why there is still a short on this one is because the signal actually goes from here to the controller, which is here, goes into this controller, then comes out, and then from here, it goes to this controller, as you can see. And this controller apparently is also shorted. We already know that one of them, I guess it didn't get this controller shorted on here because this also goes somewhere. Let's find out where this is going. So it's no longer shorted, but it comes out here. And as it comes out here, it goes into this pin that ends up and connected to one of these. It's connected to the second pin. So the good news is that it didn't blow out this pin here, but it still blew out the other pin. So we removed the controller, one of the shorts is gone, the other one is still present. So that indicates that both of these controllers are, at this point, busted.
Okay, so far we've determined that both of these controllers that are responsible for measuring the current and controlling the outlets, for that matter, on this EB832 have been damaged because of the short on one of the outlets. I removed the second controller. We knew that we realized that this was where the damage came from as well. Now the short is all gone, so we'll have to attempt to replace these controllers. So let's get under the microscope and have everything cleaned up and the new controllers installed. Alright, starting on the left side, cleaning up all of the pads. Need to do a little bit of cleanup. Looks practically brand new. Now we just need to add some leaded solder to all of the pads. Okay, that should be good. Let's do the other side. Again, a bit of cleanup. And some fresh solder. Alright, so now is the time to get a couple of brand new controllers. These are PSOC4 type of controllers. Extremely hard to find in this day and age of component shortages. Alright, I will position and work on them one at a time. First we'll need a little bit of flux. I'll start on the left side. And then the right side. Brand new controller goes over on the left side. Position it roughly We'll get it right under the microscope. And the right side. Okay, that's roughly good enough. Let's get under the microscope and put them in. Since it's such a large controller, I'm just going to have it held in place by a couple pins first, and then use the hot air to um, fix everything else in place. Okay, that should be sufficient. Now let's put it in place with hot air. You probably can't see the whole chip in the video under the microscope. Let's heat it all up and make sure that it all sits well. The chip is moving under the surface tension. That's good. And we'll have to work through all of the pins with the iron in a minute. But in the meantime, let's get the right one in place as well. Same exact procedure. Just need to position it better. Secure a couple pins. These controllers are supposed to be extremely inexpensive, and that's why Neptune chose it for this unit in such quantities. But due to the parts shortages lately, the prices have gone up immensely, and it's also incredibly hard to find. This is the beginning of 2022 right now, and I think the expected shipments for retail are looking into mid-2023. And the prices of what is available reflects such a dire shortage. Alright, looks like we got it. Now all what's left is to walk through all of the pins and make sure that everything is sorted, so we'll need a little bit more flux all over the place. Alright, a bit of cleanup. Alright. Yeah, check out the final product. Just as good as the original, if not cleaner. Okay. Well, alright. So obviously just replacing controllers with brand new ones is not going to do us any good, because they're supposed to, these are PSOCs, they're supposed to run firmware that does all of them, collecting the measurements from each individual outlet, communicating with the main controller, shutting the outlets on and off, perhaps that type of thing. So we have to reprogram both of them now. Now, Neptune's been nice as always. Much like they provided the programming header for the main controller, they also have programming headers for the PSOCs. They are actually on the other side here. Kind of hard to reach, but let me see if I can show you those. Really, really dark in there, but if you look, perhaps through here, a bit of light, you can see there is a header over here, and that's the programming header for the left PSOC, and there is one over here as well, somewhere. Even harder to see, but it's over here for the right PSOC. So we'll have to just figure out how to program this. So to program this time around, I have a very simple PSOC programmer, very, very basic. Let's try to plug it in, see if we can program this. All right, so far so good. Now let's see if we can connect to it. Lights look good. All right, ready to program. Let's see if this works. Now let's disconnect everything and connect the other side and program the right side. Okay. All right. Looks like programming's all done. Well, and now the big question is, will all of this work? Let's plug it in, find out. Okay, so first, let's just plug it into power, make sure that nothing smokes. I've heard some clicks, sounds like the 24 and the 12-volt power supplies are both on. Yeah, all of the LEDs are on. Well, this will be all right. Yep, I've heard clicks. I actually heard clicks of relay switching. I think we might have gotten it. Let me actually hook up the face panel to this so that we can visually see that everything's working. All right, so now that we have it partially assembled, I also hooked up a load, a simple light bulb, to see if it actually turns the relays on and off. So let's plug it in and see if we fixed it. All right, the light's flashing. Let's connect to Apex. All right, connected. Looks like A and B's are on. We don't really care as much about A and B's as we do about the 110 volt, 120 volt outlets. Oh, look at this. The voltage reading is accurate, 120, perfect. Let's turn off both of the link A and B. And let's turn on, let's turn on number 2 because that's where my light is connected. So it's connected, the light is on, can't see it, but trust me, it's on. Let's wait until we see some wattage on that outlet. See if it registers anything. And there it is, 12 watt, 0.1 amp. And then we can turn on more outlets. And everything seems to be working. So both of the controllers engaged, both of the controllers are doing the right thing. Let's actually make sure that the second controller is also measuring proper wattage. Let's plug it in over somewhere on this side. Let's make this outlet 4, I guess. Let's turn number 4. The light is on. Let's wait for the wattage to show up. Takes a little while to register, and there it is. The reading is slightly off, so maybe recalibration's in order. But other than that, it seems to be working. Well, all right. So let's go over what happened with this particular EB832. Again, I have 2 of these for repair from the same user who, again, plugged in a faulty heater or something along those lines, or a pump, and blew up both of EB832s. But when that occurred, the shunt resistors got blown, of course, and they sent high voltage through these resistors over to both of these controllers. Both of the PSOCs were on this unit. Both of the PSOCs are fried. On the other unit, only one of the PSOCs is fried, I think. In any case, what we had to do is we had to replace the shunt resistor that got damaged, replace the 1 kilo ohm resistor, the quad kilo ohm resistors over here, and unfortunately we also had to replace both of the controllers. Of course, replacing just the controllers with brand new ones are not going to help any. We had to reprogram both of them, and it looks like reprogramming worked, and this EB832 is now back in operation. This was a fairly complex and uncertain repair. I'm glad that it all worked out. I hope that you've learned something new and interesting in this particular repair. If you enjoyed it, please like and subscribe, and I will see you next time.